All right, so we've got quite a bit of material here on Boston Dynamics,
Yeah.
and it looks like a lot of it comes straight from their website.
Yeah, looks like it.
So we've got their products, solutions, even stuff about their R&D with Atlas,
Mm-hmm.
even some stuff about their legacy robots, and even like company info and resources.
It's very thorough.
Yeah, so I think our mission today should be to sort of like extract some key insights into their, robotic capabilities,
Okay.
especially like Atlas,
Right.
and then also see what their vision for the future of like these mobile robots are.
Sounds like a plan.
So when you hear Boston Dynamics, you probably think of those videos of Atlas doing like crazy parkour and backflips.
Yeah, of course, that's what they're known for, right?
Right, but if you go to like their product section, you realize there's a whole lot more going on.
For sure.
Like they've got Spot, of course, which is like their agile mobile robot.
Right.
But then there's also things like Orbit, which it seems like is a platform for like managing a fleet of spots.
Yeah, you can kind of think of it like the command center for your spot robots.
Okay,
If you've got a whole team of them out doing inspections or whatever, you can keep track of them all through orbit.
that's cool.
Yeah.
And then there's even just a robotic arm by itself,
Yep.
which I imagine like adds a whole other level of interaction to something like Spot.
Oh, yeah, for sure.
Instead of just like observing and recording it, can like actually start manipulating stuff.
Exactly. And that's one of the interesting things about how they've set things up. They're
Okay.
not just selling individual robots.
Uh-huh.
It's more like they're offering a whole suite of tools, and you can kind of mix and match depending on your needs.
I see. So like modular.
Yeah, exactly. Like you can start with a spot base and then add on the arm if you need it.
Okay.
And then if you're operating multiple spots, you can bring in orbit to manage the whole fleet.
Okay, cool. And then on top of that, they even have like specialized payloads.
Right.
So you can like further customize Spot for like a very specific task.
Exactly. So it's way more versatile than just those viral videos might suggest.
So it's like, it's not just about the flashy stuff.
Yeah,
There's like actual real world applications here.
absolutely. And that's really clear when you look at their solutions section.
Okay, let's do that.
They lay out exactly how they envision these robots being used in different industries.
All right. So one of the big ones is inspection, right?
Yeah, big time.
And they're doing like everything. It seems like thermal and visual checks,
Uh-huh.
acoustic monitoring for like leaks,
Yep.
and even like automated perimeter patrols.
Perimeter is interesting, right? Because you can immediately see how that could be applied to security and surveillance.
Yeah, you could have like robot guards basically.
Pretty much. And because they're robots, they can operate 24/7. They don't get tired. They don't need breaks.
And they're probably a lot more observant than a human guard.
Potentially, yeah. They've got all those sensors feeding them information.
Okay, so moving on, we've got safety and response.
Right. Another huge area for robotics.
Yeah, this is where I think robots can really shine, like, going into situations that are dangerous for humans.
Exactly. And they list a bunch of examples.
Yeah, like remote investigation, nuclear decommissioning.
Uh-huh. CBRNE threats.
Right.
Which is chemical, biological, radiological, and nuclear.
And even EODite, like explosive ordnance disposal.
Which is bomb disposal based.
So all of this stuff is super high risk.
Absolutely. And I mean, that's one of the main arguments for using robots in the first place.
Okay.
It allows us to project human capabilities into dangerous situations, but without putting people at risk.
That makes a lot of sense.
And even just remote investigation, like being able to send a robot in to gather information before sending in a human team,
Right.
that can be incredibly valuable in an emergency situation.
Okay, so another one that caught my eye is digital twin.
Okay.
This whole idea of using robots for laser scanning and site documentation.
Interesting, right?
Like, think about it for like a huge construction site.
Yeah.
You could have a robot constantly updating a 3D model of the entire site as it's being built.
That would be massive for planning and coordination.
Totally. And it's not just construction, like any large industrial facility could benefit from this.
For sure.
Okay, and then rounding out the solutions, we've got warehouse automation.
Right.
And specifically, they talk about container unloading.
Which is a task that's ripe for automation.
Yeah, it's like really physically demanding and repetitive.
Exactly. And it can create bottlenecks in the supply chain.
Right.
So by automating that process, you can make things much more efficient.
And probably improve worker safety, too.
For sure, taking humans out of those potentially hazardous situations.
So if we look at the industries they list, it's pretty diverse.
Yeah, they're not limiting themselves to just one or two sectors.
Right, we've got manufacturing, energy, and natural resources, academia and education, government, warehouse, and logistics.
It's a pretty broad spectrum.
So do you think their technology, like, genuinely translates across all these different sectors?
I think it comes down to the core capabilities of their robots.
Okay.
Mobility, manipulation, perception.
Uh-huh.
Those are things that are valuable in a lot of different contexts.
Right, like whether you're inspecting a factory floor or traversing a construction site or operating in a warehouse.
Exactly. Those fundamental abilities is you a really versatile platform.
I see.
And then the specific solutions they offer are basically just tailoring those abilities to the particular challenges of each industry.
Okay, so let's talk about Atlas.
Yeah, the star of the show.
They call it their most dynamic humanoid robot, and it's now fully electric, and they say it's designed for real-world applications.
That's a key phrase, right? Real-world applications.
What do you think that implies about their goals for Atlas?
I think it means they're serious about moving beyond just research and development.
Uh-huh.
They want to create a humanoid robot that can actually perform useful work in environments that are designed for humans.
So, like, not just doing backflips in the lab.
Exactly. They want to see Atlas out there in the real world making a difference.
Okay.
And the switch to electric is interesting, too.
Why is that?
Well, for one thing, it makes the robot more power efficient,
Okay.
and it can also make it quieter, which is important if you're going to be operating it around people.
Right.
And the fact that they've been working on this for decades, like Atlas isn't just some new project.
Yeah.
It's the culmination of years and years of research.
So they highlight some key capabilities of Atlas.
Right.
First one is athletic intelligence,
Uh-huh.
which is basically the robot's ability to connect perception and control so it can adapt on the fly.
So it's not just blindly following a pre-programmed set of instructions.
Right. It's actually reacting to its environment and making decisions in real time.
Exactly. And that requires some pretty sophisticated technology.
Yeah, like what kind of stuff?
Well, you need advanced sensors to perceive the environment accurately.
Okay.
And then you need powerful algorithms to process that information and make decisions about how to move.
So this is like cutting-edge stuff in terms of computer vision and control theory.
Oh, yeah, absolutely.
Okay, next up is dynamic manipulation.
Right. So this is about using the robot's hands and its full range of motion to interact with the world in a meaningful way.
And that seems like a whole lot harder than just walking around.
Oh, yeah, for sure.
Like, walking is impressive, but actually using your hands to manipulate objects in a complex environment.
That's a whole other level of dexterity and coordination.
And I imagine it also requires a lot of spatial awareness.
Absolutely. The robot needs to understand where its hands are in relation to the objects it's trying to grasp.
Okay, so then we've got real-time perception.
Right.
And this is where Atlas uses depth sensors to create what they call point clouds of its environment.
So basically, imagine the robot seeing the world as a huge collection of 3D data points.
Okay.
Each point represents a specific location in space,
Uh-huh.
and together they form a detailed 3D map of the surroundings.
So it's like a 3D scan of the environment.
Pretty much. And this allows the robot to understand the shape, the size, and the position of objects.
Which is essential for navigation and manipulation.
Exactly.
Okay, and finally we have model predictive control.
Now, this one sounds complicated, but the basic idea is that the robot is constantly predicting its own movements,
Okay,
and then it's using those predictions to adjust its actions in real time.
so it's like thinking ahead.
Yeah, you could say that.
And why is that important?
Well, it allows the robot to perform much more complex and dynamic movements.
I see.
By predicting the outcome of its actions, it can make adjustments to stay balanced and achieve its goals.
So they link Atlas back to their broader vision, which is basically developing robots that are mobile, perceptive, and intelligent enough to become commonplace.
Right.
And they seem to think that the humanoid form is like a key part of that vision.
Yeah, they believe that if robots are going to integrate seamlessly into our world, they need to be able to move and interact with the environment in the same way that humans do.
And that means having a body that's similar to ours.
Right, because our world is designed for human bodies.
Yeah, I mean, everything from stairs and doorways to tools and furniture.
Exactly, it's all built around our size and shape.
So a humanoid robot would theoretically be able to navigate and interact with all of that stuff much more easily than a robot with a different form factor.
Makes sense, right?
Yeah, definitely. So let's move on to their innovation and R&D philosophy.
Okay.
They talk about pushing the limits of robotics and tackling the next commercial frontier with Atlas.
So it sounds like they see Atlas as more than just a research project.
Right, they think it has the potential to be a commercially viable product.
Which makes sense given their track record.
Yeah, I mean, they've consistently been at the forefront of robotics innovation.
Absolutely, and they've spun out a number of successful companies over the years.
So they have a history of turning research into real-world applications.
For sure, and they're clearly hoping to do the same with Atlas.
They also talk about the meticulous design and manufacturing and calibration of Atlas.
Right, they highlight the high power, the dynamic control algorithms, and the lightweight design.
And they use some pretty advanced materials too, right?
Yeah, they talk about using 3D printed titanium and aluminum. So this is clearly a very sophisticated piece of engineering.
Yeah, I mean, just achieving that combination of high power for dynamic movement and lightweight structure for agility.
That's a huge challenge.
And then on top of that, you've got to develop the control algorithms to actually harness all that power.
Exactly. It's a remarkable feat of engineering.
So they also give us a little glimpse behind the scenes at their robotics lab.
Yeah, they talk about their iterative process of testing new builds and ideas,
And it sounds like it's very much a hands-on trial and error kind of approach.
which is typical for robotics research.
Yeah, I mean, you're constantly building and testing and refining your designs.
Absolutely, and that's how you make progress.
So finally, they have a whole resources section on their website.
Oh yeah, it's a treasure trove of information.
They've got case studies, blogs, videos, webinars, white papers, and ebooks.
And even development documentation for their Spot SDK.
Right, which is pretty cool because it means that they're encouraging other people to build on their platform.
Yeah, they're opening up their technology to a wider community of innovators.
And that could lead to some really interesting new applications for their robots.
For sure.
They also have a news section and a legacy robots section.
Which is great for understanding their history.
Yeah, like looking at the robots they've developed over the years gives you a real appreciation for how far they've come.
Absolutely. It shows you the evolution of their thinking and their technology.
So to wrap things up, it's clear that Boston Dynamics is operating on multiple fronts.
Yeah.
They've got commercially available robots that are already solving real-world problems.
Uh-huh.
And at the same time, they're pushing the boundaries of what's possible with their research on Atlas.
Exactly. They're a company with a very clear vision for the future of robotics.
And that vision includes both practical applications and ambitious long-term goals.
Absolutely. They're not just about making cool robots.
Right, they're trying to change the world.
And they might just succeed.
So this deep dive into Boston Dynamics really gets you thinking. Considering how fast this technology is advancing,
Uh-huh.
what unexpected areas of our lives do you think are going to be impacted by these highly mobile and intelligent robots in the near future?
It's a great question.
Yeah, I think it's something we should all be thinking about.
For sure.
All right, well, thanks for joining me on this deep dive,
It's been a pleasure.
and we'll see you next time.
Sounds good.